I thought I'd discuss the concept of a function, and this is a very general discussion. I'm not really going to do many examples. Function basically relates to collections of objects, and it's a rule. A function satisfies a rule, and that is for each object in the what's called the domain, you associate one object in the range. That's what a function is. So you have like a collection of stuff, say numbers, and then you associate to every number a color, say. And it doesn't really matter how you do it. You can just say all numbers we associate red to. Or you could say if it's positive, red. If it's negative, blue. If it's 0, purple. Those things are functions. One way to see that functions are rather important in mathematics is the fact that we give functions many names. Some of the things that you might be familiar with in mathematics you might not recognize as functions, but these things are. So here are some of the names we give functions. Function, mapping, homomorphism, bijection, isomorphism, homeomorphism, sequence, series. I think there's a bunch more, but those are the simple ones that come to mind. And the reason there are so many functions, so many names for a function, is because functions are important. They're how we do mathematics. In fact, pretty much every theorem is just this statement about functions. Often you'll show that a function is of a certain subtype, like in isomorphism or bijection. That's a big part of functions. Another time, what you'll do is show that two functions are actually the same function. And that's really, a very large percentage of mathematics. Functions help us investigate structures of sets, which are collections of objects. And that's all for now.